Hello, everyone. Welcome back. Thank you for joining us. Good afternoon. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, People's Republic of California.
Yeah, and just a plug for that, Proposition 50,
No,
please vote no on that. If you're in California and you're listening to us, that is a no-go
it's
deal.
so funny. I was listening on the radio on Fox of all, and there's a commercial about it, and the lady says, a nonpartisan, fair, independent. You kidding me? That's what we have now. They want to change it to a partisan deal. It's just
Vote no
duplicitous.
on 50. If you know anybody in California, encourage them to vote no on 50, please. Yeah. So here we go.
I'm Steve Richardson, and I approve this message. Scientist. I just gave my last name.
Yeah, it's not the
first time. Man.
Not the first time. Want to start over?
No.
Okay.
Scientists have found that on Titan, substances that should remain separate can actually combine under freezing conditions. NASA and Chalmers University researchers discovered that hydrogen cyanide can form stable crystals with methane and ethane, overturning a basic rule of chemistry. The finding offers new clues about how life's essential molecules may have arisen in harsh, prebiotic environments. The team's research was published in the journal PNAS on July 23rd, 2025. Would you like to know more? I would.
I think I brought this up when I was in high school to our chemistry teacher, and that's why he threw me out of his class. So, Mr. McGregor.
What? Ethylene?
Yeah.
Ethylene? Oh.
Yeah, changing the laws of chemistry.
Oh.
Yeah, he wasn't having that.
He wasn't having that.
No. For decades, scientists have been captivated by Saturn's largest moon, Titan, believing that its history could reveal how life began on Earth. The frigid world, wrapped in a thick atmosphere rich in nitrogen and methane, shares striking similarities with the conditions thought to have existed on our planet billions of years ago. By examining Titan's chemistry and climate, researchers hope to uncover clues about the processes that pave the way for life to form.
Okay, so how can scientists make a leap billions of years ago that our atmosphere had methane? What proof of that?
I don't know.
Where do they get the idea?
Smarter guys than me, that's for sure. So I don't know. It's what they do, right?
Yes. Martin Rahm, an associate professor in the Department of Chemistry and Chemical Engineering at Chalmers University of Technology, has spent years exploring Titan's complex chemistry. His team's recent discovery that certain polar and non-polar substances can actually combine under Titan's freezing conditions may provide valuable direction for future research on the moon.
So how do these guys do they get grants and donations for this kind of stuff so they can do these researches?
You got to put food on the table. Yeah, they must.
The team's research reveals that methane, ethane, and hydrogen cyanide, compounds found in abundance on Titan's surface and in its atmosphere, can interact in ways scientists once thought possible. Impossible, sorry. The fact that hydrogen cyanide, maybe that's what I said to Mr. McGregor, that it was possible. Anyway, the fact that hydrogen cyanide, a highly polar molecule, can form solid crystals with non-polar substances such as methane and ethane is remarkable, since these materials normally remain separate, like oil and water.
See, I can understand that. Oil and water, they just separate, right? All right, the background to the Chalmers study is an unanswered question about Titan. What happens to hydrogen cyanide after it is created in Titan's atmosphere? Are there meters of it deposited on the surface, or has it interacted or reacted with its surroundings in some way?
To seek the answer, a group at NASA's Jet Propulsion Laboratory in California began conducting experiments in which they mixed hydrogen cyanide with methane and ethane at temperatures as low as 90 Kelvin, which is about negative 180 degrees Celsius.
That's cold, man.
Which I don't know what that would be in.
It's not degrees, survivable.
Yeah, we won't even go there. At these temperatures, hydrogen cyanide is a crystal, and methane and ethane are liquids.
When they studied such mixtures using laser spectroscopy, a method for examining materials and molecules at the atomic level, they found that the molecules were intact, but that something had still happened. To understand what, they contacted Martin Rahm's research group at Chalmers, which had conducted extensive research into hydrogen cyanide. They're the experts.
Yep. The Chalmers researchers used large-scale computer simulations to test thousands of different ways of organizing the molecules in the solid state in search of answers. In their analysis, they found that hydrocarbons had penetrated the crystal lattice of hydrogen cyanide and formed stable new structures known as co-crystals. Discovery challenges one of the best-known rules of chemistry, but Martin Rahm does not think it's time to rewrite the chemistry books. Neither did Mr. McGregor. So,
yeah. So you actually opined on ethane and...
I don't know, but I wasn't in this class but more than a half a period.
You really pissed him off, huh?
Oh, I know. There was no way, man. I think I told you before. It was the periodic table. We were told we had to memorize that periodic table, and I'm looking at all these numbers and letters. I'm thinking, they don't make any sense to me. But I went home and told my dad. He was not very happy because I had aspirations of becoming an engineer. And you had to pass chemistry to do that. Yeah. More than one time, more than high school chemistry.
Yeah.
So, but anyway.
Organic chemistry,
yeah.
All right, in 2034, NASA's space probe Dragonfly, we've talked about that, is expected to reach Titan with the aim of investigating what is on its surface. Until then, Martin Rahm and his colleagues plan to continue exploring hydrogen cyanide chemistry, partly in collaboration with NASA.
Saturn's largest moon, Titan, is among the solar system's most unusual worlds, and it may share features with Earth's early evolution. Titan is surrounded by a thick atmosphere composed mostly of nitrogen and methane, a composition that could resemble the atmosphere on Earth's billions of years ago, before life emerged. Because we've talked about that, right? Couldn't happen. I mean, life wouldn't happen with all this stuff on there, right? Wouldn't be able to breathe. So, sunlight and other radiation from space cause these molecules to react with each other, which is why the moon is shrouded in a chemically complex orange-colored haze of organic compounds. One of the main substances created in this way is hydrogen cyanide.
So isn't methane flammable?
I believe it is.
So
isn't that what you see burning off like in the oil fields and stuff?
Yeah,
you see that? Yeah.
So if you strike a match on there, the whole planet's going to go up, isn't it?
Could, yeah.
Dang. I wouldn't want to be there.
So don't do that.
Yeah, don't smoke on Titan, okay?
Titan, right.
No smoking moon. Titan's extremely cold surface is home to lakes and rivers of liquid methane and ethane. It is the only other known place in our solar system, apart from Earth, where liquids form lakes on the surface. Pretty cool. Titan has weather and seasons. There's wind, clouds form, and it rains, albeit in the form of methane instead of water. Raining methane. That's just crazy.
Fire in the sky.
Yeah. I wonder if dragons came from Titan. You think dragons did?
Or they're breathing methane? Is that what you're getting at?
Yeah, like the fire that they breathe. There is wind, clouds, and clouds form and it rains, albeit in the form of methane instead of water. Measurements also show that there is likely a large sea of liquid water many kilometers below the cold surface, which in principle might harbor life.
In 2028, the U.S. Space Agency, NASA, plans to launch the Dragonfly space probe, and we've talked about that before, which is expected to reach Titan in 2034, the year before California is going to get rid of all petroleum-based cars. Yeah. The aim is to study prebiotic chemistry, the chemistry that precedes life, and to look for signs of life.
Yeah, so just that you mentioned that. So 2035 that we're going electric. What if nobody's producing electric vehicles? We just going to stop driving because we can't get gasoline?
What if we have the same grid that we have now and we can't charge all the electric vehicles?
Well, you'd be on a schedule then. You just have to be on a schedule.
Yeah, so what do? You work from home a couple of days a week because you can't charge your car, and
these are problems that the brainiacs in politics didn't think about. You know, they didn't think it through.
Yeah,
just had a bright idea.
Thanks, Gavin
Newscomb. All right, thanks a lot, folks. We'll see you tomorrow morning.
Take care, everyone. Thank you.